Welcome to another episode of Behind the Science on Location. I'm your host, Jennifer Fournier. Death investigation toxicology, or postmortem toxicology analysis, is critical in cases where drugs or chemicals may have played a role in an individual's death. Since results may be used in a court of law or provide closure to a decedent's family, the accuracy and precision of the analytical technique is essential. The matrix can be the trickiest part. You never know what you will find and have to work with. Is it possible to use one technique to test a variety of different matrices? Let's take a trip to a mock crime scene to see just what we encounter. Sabra, so where are we?
Well, hi Jen. Well, welcome to Baston University's outdoor research facility, where we train graduate students in law enforcement on crime scene investigation. And in addition to that, we do decompositional studies.
So it looks like we have some evidence here.
Yes, so this is an example of a mock crime scene, and in addition to the outline of the body, we also have some potential items of evidence.
So why are gummies here?
That's a great question. So today drugs can come in all sorts of formulations, so including gummies. So this would be an item that we would collect.
It looks like that item is right up Claude's alley. I say we collect it and head back to the lab.
Absolutely.
Claude, we have some evidence for you from our crime scene.
And what do we have here?
Looks like we have gummies. Should be pretty easy to analyze, right?
Absolutely not. These are actually in the solid sample category, and this will require more sample prep time. At this point, this will have to be turned into a sample that we can analyze by SP or liquid extraction. This will require additional step of extraction.
Yeah. So, like this gummy fruit candy, it's sort of similar to a tissue sample where we actually have to break it down so we can get it finally into a liquid form that we can analyze. So traditionally we do a homogenization step where we grind it up with a solvent of some type. That process historically can take anywhere from hours to days.
Sounds pretty easy to understand, but let's go to the whiteboard.
So let's start with the extraction process. So here you can see that we have gummy bears, and we have to get these solid substances into a liquid format and then take it on to an extraction process. So once we homogenize the gummy bears and we get it into a liquid format, we can take and collect the supernatant, dilute it with about 100 mils of millipore water, add 2 mils of formic acid, and then load that onto our solid phase extraction cartridge. And in this application, we use the max 150 milligram cartridge. We then perform 2 wash steps with 2 mils of water with 0.5% ammonium hydroxide, and then a wash step 2 where we take 2 mils of a percentage of methanol with water with 0.5% ammonium hydroxide. We then elute with either 1 mil of methanol with 2% ammonium hydroxide or with 1 mil of methanol with 2% formic acid. At this point, because we're using multidimensional chromatography, there's no need to evaporate our sample. We can take it right onto the instrument. So at times, we actually don't know what drug to target in a biological matrix. Therefore, if we find a substance like this at the scene, either at the scene of a crime or next to a decedent, we can actually analyze the substance, identify what drug we should actually target for the biological matrices.
Well, that was an on-location adventure. In this episode, we had a matrix that I would not have even thought of, gummies. We showed how edible sample prep can be achieved, and you can use this technique with multidimensional chromatography, not only for that matrix, but for other complex matrices. If you want to learn more about what those matrices are, check out the link below. And join us next time for another episode of Behind the Science on Location.